Good afternoon, everyone, and thank you for joining me on my presentation about navigating a virtual ocean. As said, my name is Ruben Vries, and I want to share with you my research on the perception of scale and how you orientate yourself in a virtual marine environment. But before we dive in, I want to share with you how I actually started off with my research, because I was studying the concepts of digital Earth, which is a very interesting framework to represent and analyze and represent data of our planet. However, what I noticed is that the focus in packages like, for example, Google Earth, or maybe the lesser known NASA's Whirlwind, is mostly focused on terrestrial areas. And as you might be aware of, is that our world is actually for over 70% consists of oceans. And those are very important for us. And they become increasingly important due to, for example, climate change. So I took a shift and I found the concept of digital ocean, which actually focuses on those marine areas. And as you're also aware of, is that of course, our world is not a 2D environment, but the ocean system is definitely not a two-dimensional environment. So a digital ocean actually asks for so-called multi-dimensional visualizations. So in short, 3D. So not 2D, when we look at a map, for example, or a computer screen, but actually the 3 dimensions when you look around. And this can be possible if you really dive in. So if you take a look at immersive multi-dimensional systems, in short, virtual reality, VR, where you can have potential new insights in data presented. So you're not looking at the data from a distance or via a computer screen, but you're actually submerged in the data set itself. But we need to remember that exploring an ocean environment is not something we're used to doing. It's very different than exploring a terrestrial environment, like walking, cycling, or driving through the city or the streets. So that provides us with a few challenges, new challenges. So how do you perceive scale and distances in a virtual environment, and specifically in a marine environment? And how do you orientate yourself in such an environment? So how do you move around? How do you navigate? And that led to the main question I worked on. How is distance, scale, and orientation experienced in a virtual marine environment? And can we build in navigational aids, and what is their influence on those perceptions? So to answer this main question, of course, I cut it up in pieces. And first of all, I started looking at, so how do you effectively navigate a virtual environment, or how do you effectively navigate at all, normally? So how do you maintain, for example, your sense of position, your orientation when you're in an unfamiliar environment? You have no familiar landmarks. Perhaps the scale of the environment is unknown, because again, if you're in the city, if you're walking around, the scale of a house or perhaps a tree, and we had some nice examples in the previous presentation, often you roughly know the scale of those objects, or familiar landmarks like the Eiffel Tower. And if you look at marine areas, and to give an extreme example, the Mariana Trench, located in the South Pacific, it's a very deep marine trench, so deep that you can actually fit an entire mountain in it, and not just the mountain, the biggest one we have. Or if you're not a mountaineer, stack the Eiffel Tower 29 times and you have roughly the same. So the scale of the marine environment is often way different than we're used to. Next to that, I mentioned that maybe we can build in something to help us out. So navigational aids. So which of these are usable or of added value in a virtual marine environment. And I came across a few, but what actually was an interesting one, at least what I thought, was signs. And you're all used to using signs if you're navigating. They indicate a direction, they can indicate a distance. But by looking at the sign itself, you can also roughly indicate how big something is, because often the height of a sign is known. As you can see on the photo below, you can roughly give an estimate on how high the water is because you know how big a sign is. So science was an interesting concept for me to look at. And finally, of course, I looked at immersion. So how do you experience a virtual marine environment when you're using a virtual reality device? Because it was shown in previous research that immersion requires potentially less navigation and effort to move around in finding the proper information on a higher level of accuracy. And even 20 years before that, when virtual reality was even a newer technique than we think of it as it is now, Muller already showed that immersion can actually improve distance estimations. But he looked at the regular city layout, so you have a familiar scale of familiar surroundings. So we did not look at the marine environment. So, okay, now what? So we recognize that we have something interesting lying here. Virtual ocean is an interesting concept. Immersion is an interesting way to navigate through your data sets. So why just focus on this using, for example, a desk study or analyzing patterns? Because as a teacher, I had access to many potential users at the university. So I came to the conclusion that actually, I think I should conduct an experiment to really test this. I want them to practice with devices. So comparing a regular computer, the PC, and how do they behave if they are using a virtual reality device. Of course, I'm looking at navigation. So I need some sort of navigation task, and they start the actual experiment. They find my search targets. And while they're doing that, they need to answer questions. So I can actually make estimations on, do they have an idea on how big something is or how far away? And afterwards, I'm going to ask them about their experiences. So I can make an estimation on how they experienced everything. Next to that, observations were made by a second person in the room, and he looked at behavior. So how did they move through the surroundings and how did they behave? Did they have certain things they did or didn't do? So of course, to be able to do this experiment, I needed an environment. I needed a virtual ocean. So what I did, I chose an existing location. So I avoided unrealistic landscapes. So I picked a space in the Great Barrier Reef because it's pretty well known and interesting to look at. And I made a 3D visualization using ArcGIS desktop. And I kept in mind that I wanted to focus on navigation tasks. So the visualization had to be as simple as possible. So that led me to the next stage. How do I create a framework? How do I choose a platform to do this? Because I want it to be immersive, it needs to be interactive. And we have a lot of software available these days, which create very shiny and polished 3D visualizations, like Vries City Engine, Unity as a gaming platform, Blender focuses mostly on 3D visualization, not per se gaming. But I wanted it to be as simple as possible. So I came to the conclusion, Minecraft. That's an interesting one. It's very simple. It works with very simple building blocks. It's not polished, completely not polished, but it allows ease of data implementation. It attracts more participants because it's a pretty well-known game and it provides user engagement as well. And of course, the big plus, I could create a full immersive virtual experience because it allows the use of a virtual reality device. So in Minecraft, I visualized bathymetric data and my navigational aids using different colors. Because Minecraft works with voxel blocks, I chose different colors to represent, for example, a different depth or a different distance. So to implement my fictive signs, I chose particular colors, in this case pink, as you can see on the image, to indicate a certain distance. It's a grid overlay with 50 meters apart. And to indicate different depths, I chose different colors as well. And the choice of colors was mainly based on, well, how visible is it if you're underwater, and does it have a bit of contrast so that you can recognize the different colors as well. Finally, I recognized the navigation task. I placed so-called artificial reefs, coral reefs, in the environment as a navigation task for the participants to find. Of course, if you want to do an experiment, you need users or participants. And to test whether VR was of added value, and of course the built-in aids, the distance indications and depth, I created two groups, a so-called control group. So that was an environment which only had one color, no built-in aids whatsoever, and a test group with an environment that had the pretty colors, as you can see on the image. And so depth indications and a grid indicating the 50 meters intervals. And in total, I had 50 participants taking place in this experiment, mostly students and a few teachers and researchers at our institute. I analyzed everything statistically with R. The questionnaires I did afterwards, the questions that I asked, of course, during the experiment, and how they behaved, everything was loaded in R, and I took a look at, for example, the use of VR, navigational aids, gender, gaming experience. I compared the different dive sites because, as I mentioned before, you can get better estimations on scale of the environment if you have known features and known objects. So I compared the dive sites, whether it mattered if they had more depth differences, for example. I looked at the individual reefs, so whether they were longer in the game, in the experiment, more or less, if they were better at estimating the distance, or became better at orientation. And I looked at what kind of variables potentially influenced their navigational abilities. Again, of course, the VR and the built-in aids, age groups, and diving and gaming experience. So as said, the larger part of my group consisted of students, 84%. Quite a lot of my participants also had gaming experience, a little over half, and almost half of the group already had experience in playing Minecraft. Some of them played it once or twice, some of them played it on a daily basis. A little less than those, 42%, actually used a VR device before as well, but most of them just used it once or twice, for example, on an exhibition to try it out. I only think there were 2 or 3 participants who actually really played a game a few times using such a device. And as much as those, 42 also had diving experience. Similar, some just on a yearly basis, some seasonal, some a little more, maybe even daily. But summing all that up, I made a choice to use a platform. Most of the participants thought that Minecraft was actually a good choice. They were not bothered that it was so simple. A few actually were, of course, a bit bothered and thought, well, it would have been nice if it looked a bit more fancy. But overall, this was a good starting point. Because they thought it was actually a great experience. They enjoyed it overall. They rated it overall on a scale of 0 to 5 with a 4.3, which is, well, quite nice. Only 8%, well, did not found it was that easy to use. That's not a lot. And 80% of them actually thought it was easy to use, ignoring the choice of setup. So if it was desktop or VR, that was not relevant yet. Which of course leaves the question, okay, but you were interested in what device, VR or desktop? Definitely VR. 76% preferred the use of virtual reality device over the desktop. Only 1% said definitely desktop. And if I remember correctly, that was a hardcore gamer and he didn't like VR. It felt more like diving, said one of the participants with diving experience. Most of them thought that the VR device added to realism and enjoyment. So it was just more fun to use it. They enjoyed it. It was more real for them. They really were in the environment. So in terms of immersion and engagement, it really gave a big plus. So that's all very fine. Enjoyment and experience, and they liked the VR. But of course, I also was interested in, is it of added value in terms of navigational abilities? Does it add something to perception of how they perceive distances and orientation? If I look at merely the use of built-in aids, they roughly spent a similar amount of time in both the control and the test environment. So that's quite similar. Apparently, if we look at a desktop setup, the males were a bit faster. And they spent an average of a little less than 9 minutes. And the gamers, again, also were a bit faster or spent less time than the ones without gaming experience. Yeah, okay. Next, of course, in line was, but how did they found it to locate the individual reefs? So at the visit of every reef, I asked them, did you find it very easy or very difficult to find this one? And of course, in the control environment and the test environment. And in this, the control environment, so again, the simple one, scored significantly better. So in this environment, they thought it was easier to find reefs. Meaning that apparently the built-in aids, so the distance indications and the depth indications, had a negative impact while they were using the desktop setup. With the VR headset, the results were very similar. But as one of the participants actually said, you're so busy already with orientation and moving, I didn't even use the aids. It was too much information for me. So when looking at effectively navigating, and then we look at, okay, were they effective in the sense that they needed to travel less distance to reach the same goal? And so were they effective in moving around? Again, if we compare the control environment and the test environment, only very, very small differences were found in the control environment. Again, the simple one, no distance indications. And apparently there, the VR device provided them with, well, a minor advantage. They seem to be a bit more effective. Observed behavior showed something similar. So without those built-in aids, participants appear to be a bit more determined in their behavior, that they knew where to go. But again, especially on the desktop. On the VR device, we saw a lot of wandering, stopping on the way, looking around. So that felt a bit different if we merely look at observations. Of course, estimating distance was a very important one. I asked them, can you give me an estimation on how far the next reef is, or how deep is this located? Again, we did that with every reef, and we compared those results with the actual measured, between brackets, in-game, the distances. And again, to give you the heads up, the blocks were 1 meter in size. It was a 1-on-1 resolution, so it's the actual area size as well. So no tricking in scales and whatsoever. Complexity of the environment, so high variations in depth or not, no significant differences. Using a VR, no, didn't really matter at all. And using distance indications, well, didn't really help apparently as well. No significant differences again. So what about the variables? The built-in aids, so the test environment and the use of the virtual reality device, both gave a negative influence on results. So they were definitely not of added value. Looking back at what they preferred the VR, but apparently that doesn't matter a lot. When looking at different aspects, apparently experienced divers do seem to be significantly better at finding reefs. Maybe that makes sense because they're used to diving or navigating through such a surroundings. So even in a virtual one, they're a bit better at that. So practice makes perfect, I suppose. It also had a positive effect on how accurate they could estimate distances. So apparently this really is something that's relevant. Gaming experience resulted in a positive effect on travel distance. So the ones with gaming experience were a bit more effective, more faster, needed less distance to travel. But again, also in this one, the aids and the VR device still had a negative influence. So it was still not helping a lot. So looking back at the choice of platform, Minecraft proved to be very user-friendly. All the participants were able to use it within 5 minutes, even if they hadn't ever heard of the game before, hadn't ever used it before. So that was a good choice. It also provided to be very effective to visualize three-dimensional data in a very fast way. I think I could create an environment, a simple one, relatively small one, in almost half a day. So that's very fast and very efficient, of course. So none of them ever used it in combination with a VR device. So of course, which led to the question, what if they practiced a bit more? What if they took a second go, and how did that work out in the results? As pointed out as well, that orientation was difficult in either setup, so even desktop and the VR one. But I think it will become easier with time. So maybe I should do this again, or maybe a third go or fourth go. And yes, I started off with males were faster, but they also had significantly more gaming experience on the desktop device. So don't get your hopes up too high. This has probably more to do with your experience in gaming. So looking at those distance and depth indications, you're so busy with orientation and moving, you almost forget them. I also discussed with one of the participants that he had a feeling that he had a need to perform. Of course, I had an experimental setup with a maximum amount of time per participant because, yeah, I couldn't spend the whole day. I had 50 to do. But he said, well, I just wanted to find all the reefs and I wasn't paying too much attention to my surroundings all the time. So yeah, perhaps that tells something about the setup of the experiment and perhaps also about some of the results. But yeah, again, a second visit could be very interesting. Immersion gave most of the participants a better feeling, more realism, and the engagement, and the best results with experienced divers. But perhaps some of you are aware that if you're using a VR device, that your sense of motion is completely different, and the use of a VR device can cause nausea. So that's why I implemented a limited field of view, as you can see on the image. So while you're moving, the image is narrowed, so you don't see the whole thing. But as noted by one of the participants, I like to have more vision while I was moving. Yeah, while you're moving, you don't see the whole thing. So they may have missed one or two reefs because of this. So to conclude, how distance, scale, and orientation is experienced in a virtual marine environment, and does it help to build in navigational aids? Age, gender, and diving experience seem to have influence on navigational experiences. So yes, male participants, perhaps slightly faster / gaming experience, and diving experience seem to be of influence here. Integration of navigational aids for now had a negative impact. And the VR was definitely preferred for engagement and experience, and of course a lot of fun if you don't get nausea, which happened on one or two occasions, fortunately. So thank you for listening, and I'm happy to answer all your questions.